Okay. So last time we have discussed the Gauss law. Last meeting we have discussed Gauss law, and we have learned that Gauss law is a tool to obtain the electric field of a certain field point using symmetry. So making use of symmetry, we'll be able to get the electric field of uh, at any point using kini siya, no? This equation. Using this equation, we have the differential form for Gauss law, and then we have the integral form for Gauss law. Again, Gauss law cannot be used for non-symmetrical systems. So we can only use this for systems that has spherical symmetry, also cylindrical symmetry, and then katong Gaussian pillbox. All right. So now let us continue with the curl of the electric field. So unsay meaning sa curl sa electric field? Now consider electric field from a point charge Q at the origin. Okay, so the electric field of a point charge is just equal to this one. So kini siya kay na-learn na ni siya ninyo pod sa 42. So E is equal to 1 over 4 pi epsilon naught Q over R squared R hat. Okay? And then, let us calculate the line integral of this field. So, to calculate the line integral of this field, we just have to consider 2 points, say for example, A and B, and then integrate it over the line. So, you have the integral of E dot dl. Now, in spherical coordinates, ang atong dl class is equal to this one. dr r hat plus r d theta theta hat plus r sine theta d phi phi hat. Okay, and then your E is along the R, nalang siya radial component R. So if you get the dot product of E and dl, you will just have this one. So all the rest will vanish. Okay, so you have E dot dl is equal to 1 over 4 pi epsilon naught Q over R squared. You have dr. So the radial component of the infinitesimal length. Okay, so integrating this from A to B, we will get this one. So unsa gani integral? We can take Q out of the integral sign. So we will just integrate dr over R squared, in which ang iyang integral kay 1 over R. Okay, so you have ang integral sa R raised to the power of negative 2. So you can actually shift this. Ini si 1 over R squared, pwede siya nimo himuong R to the negative 2. And then, integrate as usual. So, na kay R minus 1 over negative 1. Okay? So, that is why here you have negative 1 over 4 pi epsilon naught Q over R. And then, this is integrated from kini siyang RA class. This is the distance from the origin towards point A, and R sub B is the distance from the origin or from the source charge towards point B. Okay, so integrating this from R sub A to R sub B, then we have 1 over 4 pi epsilon naught. Nawala ang negative sign kay giuna niya ang R sub A, no? So this should be negative 1 over 4 pi epsilon naught Q over R sub B minus Q over R sub A. So para ma-simplify siya lang tawon, simplified, i-shift na to ang duha Okay, so nawala ang negative sign. Or ato ang i-distribute ang negative sign, we get 1 over 4 pi epsilon naught Q over R sub A minus Q over R sub B. Okay. Now, if we integrate this over a closed path, so say for example, if R sub A is equal to R sub B, then integrating this over a closed path, we will get 0. So if we get the closed integral of E dot dl, so for example, if R sub A is equal to R sub B, then kini siya, mahimon ni siyang 0. Okay? So Q over R sub A minus Q over R sub A, kung pareha ni sila, this will become 0. Now, if we apply Stokes' theorem, so nakay closed integral of E dot dl is equal to 0. Now, Stokes' theorem, if you can recall, makita ninyo class. Can you see this? Okay, so Stokes' theorem says that the closed integral of f dot dr or f dot dl or v dot dl atong gigamit sa to ang previous discussion is equal to the surface integral of the curl of the vector dot ds. Okay, so sorry, you have this one. Wala na niya gisulat no, but when we apply Stokes' theorem here, naakay surface integral of the curl of E dot dA. Okay, so here, since the closed integral of E dot dl is equal to 0, then it follows that the curl of E is equal to 0. So this is always true. Now, if we have many charges, the principle of superposition states that the total field is a vector sum of their individual fields. So we know from the superposition principle. Okay, so for electric fields, we have this one. Electric field is equal to, the total electric field is just equal to electric field 1 plus electric field 2 and so on. Okay, so we can apply atong mga rules, class, for differentiation. So you have the curl of E is equal to the curl of the individual charges, the curl of the sum of the individual electric field due to each charges. Okay. Now, this is just equal to, this is just equal to the curl of E sub 1 plus the curl of E sub 2 plus the curl of E sub 3 and so on. And this is equal to 0. So, in general, for any static charge distribution, the curl of E is always equal to 0. Okay? So it is always equal to 0. And we will learn later why this is so. Sa ganito itong na-learn sa atong previous nga discussion, the curl of a gradient is always equal to 0. Sakto ba? So, si electric field di is somehow, it can be expressed as a gradient of some scalar function. All right. So, okay, so unsa man ni siya nga scalar function? So here we will introduce the electric potential. By the way, class, Taman lang ta 8 o'clock because I will go to the office para makaklase po ko sa ako ang next class. Kaya wala ko nakaklase last time. Alright. So, what is the electric potential? Ano may idea ano kung saan ang electric potential? So, electric potential is just like gravitational potential. Now, can we apply the concept of potential first introduced in mechanics to electrical system and find the law of conservation of energy? So, we have here a standing question. So, katubang concept sa potential sa mechanics kay the same ra ba to sa, or can we apply it to electrostatic systems? Okay, so we can define an electrostatic potential energy that is analogous to the gravitational potential energy and apply the law of conservation of energy in the analysis of electrical problems. So potential is a property of a point in space and depends only on the source charges. So it depends only on the source charges. Potential is not equal to potential energy. So naa kay electric potential, okay, which is denoted by V. And then you also have electric potential energy, which is denoted by U. Okay, so potential is not the same as potential energy. Okay, so let us take a look at the analogy. So the motion of a particle with positive charge Q in a uniform electric field is analogous to the motion of a particle of mass M in uniform gravitational field near the Earth. So we have learned from mechanics that natay gitawag nga work energy theorem. So for potential energy, we have learned that the work done to a system is equal to the change in the potential energy. So sa mechanics class, atong na-learn dito, kanatay two types of potential energy. One is gravitational potential energy and then the other one is the elastic potential energy. Okay, so for electric potential energy, it is somewhat like the gravitational potential energy. So the charge can be thought of as the mass, okay, that is moving in the gravitational field. So here, ang atong field is the electric field. Okay, so if the work is greater than 0 or is positive, then the work is done by the external agent on the charges. But if the work is negative, the work is done on the external agent by the field. Pareha ra gyapon sa gravitational potential, no? Kung negative ang work, that means ang system ang nag-work. Pero kung positive ang work, then katong force ang nag-work. The applied force is working. Okay. So potential energy depends not only on the source but also on the test particle. Okay? So ang potential, dependent lang siya sa source charges. So it doesn't matter kung unsay mga charges nga nakapalibot sa iya, but the potential energy is dependent on the source as well as the test charge. Okay? So it will be more convenient if we can define a potential function which is function of the source only. Okay, so amon siya, how does this work? Take a look at this. Okay, so here, naka-charge that is moving from a region of lower potential to a region of higher potential. And then, okay, so, sa maning QE. So, here is QE. So, we learned that QE is a force, no? Q multiplied by the electric field is equal to the force. So, here, the electrostatic uh, field, ang field class, it produces or nakay QE that is going downwards. Okay? So, if the charge is going up, so this is the direction of the charge, then ang murag maka-feel siya og some kanang potential no due to this electric field. Okay? So, the charge is going up and then akay electrostatic force that is directed downwards. Okay. So the charge is working here. Okay. So the same with this. So unsa man ni siya class? This is the direction of motion sa imo ang is this the mass? Okay, so di siya maklaro. All right. So, what is the unit of potential? So, if the unit of electric potential energy is joules, ang unit sa potential class is volts. Okay. So, how is potential and potential energy related? So, when a charge Q moves between 2 points in the electrostatic field, the change in the electric potential is defined as the change in the electrostatic potential energy per unit charge. Okay, so this is the relationship between the electric potential and the electric potential energy. So, the electric potential energy, the change in the electric potential energy is is equal to the change in the electrostatic potential energy per unit charge. So the SI unit of electric potential is volt, which is equal to, so you have this one, iyang unit kay joules divided by coulomb. Okay, so joules per coulomb, or joules is 1 joule is equal to 1 Newton meter. So you can also use this unit. So 1 Newton meter per coulomb. 1 volt equals 1 joules per coulomb, or it is also equal to 1 Newton meter per coulomb. Okay. So as mentioned, V, the potential is a scalar quantity that depends only on the field set up by the source charges and not on the test charge. Okay. Now, ang magmatter the class is the change in the potential difference. So, kung sa inyong 42 no, Physics 42, University Physics 2, you have learned that for a given, kung nakay, sa pangalan ani, circuit, you need to, in order for the circuit to work, dapat nakay mga certain components. And one of that component is a battery. Okay, so the battery supplies, mag-supply siya may mag-supply og energy no sa imo ang system, sa imong circuit. And at the ends of the battery kay na siya potential. Okay, and then what for example 9 volts nga battery, that is actually the potential difference between sa tawag ana, the terminals of your battery. Okay, So only changes in potential are significant. So rather than the specific value of the initial V and the final V, so ang magmatter lang is the change in the potential, okay? Or we call this the potential difference. It is convenient to choose the ground connection to Earth as the zero of potential. Okay, so the potential at a point is the external work that we need to bring a positive unit charge at constant speed from the position of zero potential to the given point. Okay, so for example, kinsay na diri? Si Rugin o si Julite. Okay, so for example, si Rugin class, kay naa siya sa isa ka point in space and then nagdala siya og charge sa iyaang bulsa. Okay, so Rugin is carrying a charge. Ibutang niya sa iyaang bulsa. Okay, so basically, si Rugin kay maka-create siya og electric field sa surroundings. Okay? And then, si Julite, kay gikan siya sa infinity. Okay? So, infinity is a region wherein the potential is equal to zero. Since layo man kay siya kay Rugin, dili niya ma-sense ang electric field dito nga point sa infinity. Okay, so si Julite kay naghinahinay siya move at constant velocity padulong kay Rugin. Okay, so since Julite is also a charged particle or is carrying a charge sa iyang bulsa, then as she moves padulong kay gikan siya infinity nowhere where dili niya ma-sense ang electric field ni Rugin. Okay, so as she moves padulong kay Rugin, she has to do some work para ma-maintain niya yung position. Okay, so for example, she wants to be in a position that is 1 meter from Rugin. Okay, so she wants to maintain that position. So in order for that to happen, dapat dapat naaibuhaton nga work. Okay, so work should be done para ma-maintain to siya nila nga distance. Okay, for example, if si Rugin kay carrying a positive charge, unsay mahitabo? Kung si Julite kay mag-carry pod og positive charge. So there will be repulsive forces. Murag ituklod ni Rugin si Julite, or due to the electric fields between the two charges, they will exert repulsive forces towards each other. So in order to maintain that particular distance, r equal to 1 meter, dapat kinaim work should be done. Okay? Kaya ang tendency, kung pareha sila charge, ang isa kay ginapush nila ang usag-usa, right? Sakto ba? Kuha niyo ang class picture.
Yes, ma'am.
And if pareha po, if they are oppositely charged, ang isa kay negative, ang isa pod kay positive, lisod pod gyapon kay i-maintain ang 1 meter nga distance kay gina-attract man nila ang usag-usa. Okay? Nakuha ninyo? Okay. So the potential at a point is the external work that is needed to bring a positive unit charge at constant speed from the position of zero potential to the given point. Okay, nakuha ninyo from infinity towards r equals 1 meter, dapat kinakaibuhaton nga work in order to maintain that particular position. Tingnan nyo ganito, kung pareha sila positively charged,
kay maglagyo sila ay igina kuan nila yung
okay, so there will be repulsive forces. So lisod kay i-maintain ang 1 meter nga distance. Kung attractive pod, so ginapull nila ang usag-usa. So, lisod gyapon i-maintain ang 1 meter distance. So, there should be work or work should be done in order to maintain that particular point. So, gikan infinity towards, say, for example, 1 meter nga distance. Okay? So, in an external electric field, both positive and negative charges tend to decrease the electrostatic potential energy. Okay, so it tends to decrease the electrostatic potential energy. The electrostatic potential energy. So, you have learned, class, no, that the potential is equal to U over Q. U over Q. So, the electric potential energy is equal to Q times V. And then we can also have an expression for U and V that is dependent on R. So we will see later an expression for U and V that is dependent on the separation distance R. Now, if the force in the electric field is dependent on the square of the separation distance R, kinetic V is U is dependent on 1 over R. Okay. So, ano to? In an external electric field, both positive and negative charges tend to decrease the electrostatic potential energy. Dili pa siya na ako ma-expound class kay wala ko kasabot. Okay? So, I will expound this one. Siguro ma-expound ni siya nato mathematically. Okay, so which side will a charged particle drift if it is in the middle of two conducting plates with potential difference? So higher or lower potential side? So we have here a question. So for example, naa kay duha ka plate, conducting plates, and then naa kay charged particle. Okay, naa kay charged particle. So if you release that charged particle, asa siya daw mo padulong? Is it in the region with higher potential or sa region with lower potential? What do you think? Class? Pareha ba siya sa ano? Pareha ba siya sa gravitational potential energy, for example? Haman ang region of lower potential, so kanang duol sa ground. Ang region of higher potential kay kanang mga tag-asughay. Okay? So for example, if you release something, well, it will automatically fall towards the region of lower potential. So the same ba kaya sa charges, no? Okay, so panahon na to, ha? In what direction will a positively charged particle move in an electric field? Can you see this one? Makita man nyo tanan nga ko ano?
Yes, ma'am. So how do you answer that one? Any idea, class? Is it dependent on ang mas manggod kung ang mas imong tan-awon kay kuan kanang dili wala manggod kay positively charged nga mass or negatively charged nga mass. But for charges, you have two charges, positively charged and negatively charged. So as you can see, kung naa kay electric field, ang difference sa gravitational force o electric force is that gravitational force is always attractive, while ang electric force kay naa kay attractive na po kay repulsive ng electric forces, no? Okay, so when it comes to potential, let us take a look at this diagram. Moving the positive test charge from location A to location B will require work and increase the potential energy of the charge. The test charge will naturally move in the direction of the electric field. Work is not required. The potential energy of the charge will decrease. Okay. So this one. Okay, so siguro you have learned from, na-discuss ba rin na to last time, no? If you have a positively charged particle, it will emanate electric field that is radially outward. I do not know if na-discuss ba rin na to. But in 42, you have learned this one, that if you have a positively charged particle, it will emanate electric field that is radially outward. Kung negatively charged, into the charge po diyang direction. So, mura siya radially inward kung unit or kung point charge ato ang gina-consider. Okay. Now, this one, plate man to, no? Atong which side will a charged particle drift if it is in the middle of two conducting plates? So, for example, you have two conducting plates. And then, this one is positively charged, and then the other one is negatively charged. Okay? So, in ani iyang direction, dili ma-drawing class. Ang direction sa iyang electric field kay padulong dito sa negative charge because it will emanate, electric field will emanate from radially, dili siya radially outward in the case of plate, kay straight man siya, no? So, pagawas gihapon siya out from a positively charged particle or positively charged plate and into the negatively charged plate. So, ang direction sa electric field kay padulong dito class, straight line. Now, if you release a charged particle here, a positively charged particle, then it will automatically drift into the direction of the electric field. So, if the electric field kay padulong dito, so dito po siya padulong di ay sa side with lower potential. The side with lower potential. Okay? So, its natural tendency is to drift into the direction of, magpaparehagyapon siya sa sa gravitational potential energy. Okay, so in mechanics, the definition of potential energy, it's already 8. In terms of the work done by the conservative force is equal to this one. The change, the work done by the force, the conservative forces is equal to the negative change in the potential. So the negative sign tells us that positive work by the conservative force leads to a decrease in potential energy. Okay, so pareha itong answer diri sa pura, no? So, padulong siya diri. So, na-decrease iya ang potential energy. Okay, so the potential energy decreases. Alright, so you have du, the infinitesimal change in potential energy is equal to F dot ds. So, work is defined as the dot product of force and the displacement vector. So that is why nakay here nakay force F dot dl or ds, infinitesimal displacement ds. And then we know that force can be expressed as Q times the electric field. Okay, so you have here a negative charge, no, negative sign. So you will inherently have a negative sign also here. You have negative QE dot ds. Okay, now we also defined dV, katong kaganina, no? The change in V is equal to the change in U. So if you wanted to have or to know the infinitesimal change in V, then it is equal also to the infinitesimal change in U over Q. Now, du from here is equal to negative Q times E dot ds. So this is your du. Divide this with u. So your dv is equal to negative E dot ds. Okay, so the potential difference is equal to the integral, the negative integral of E dot ds. Okay, so we have here a definition of the potential difference in terms of the electric field. Okay, so the potential difference between 2 points A and B is equal to the negative integral of E dot ds, or pwede na po na siya E dot dl. Okay, now since the electrostatic field is conservative, the value of this line integral depends only on the endpoints A and B and not on the path taken. Okay, so for conservative fields, dili magmatter ang imo ang path nga gitake. Okay, so the same with murag nakasolve na taan ni class last time. Okay, so ang magmatter lang is the initial and the final points. Okay, so the endpoints A and B. All right, now in differential form, so natay integral form of the potential difference, we will also express it in terms of the differential form. Okay, so this is what I am talking about kaganina, no? We have obtained the curl of the electric field, and it is equal to 0. So the fundamental theorem of gradient states that kini siya is equal to the gradient of some scalar dot ds. Okay, so the gradient of some scalar dot ds, and VB, the potential difference, is equal to the negative of the integral of E dot ds. Therefore, E is equal to the negative of the gradient of some scalar V. So this scalar is actually the potential. So electric field is equal to the negative gradient of the potential. Okay, so this is the differential form of the electric potential. All right, so the electric field is a very special kind of vector function whose curl is always 0. So you have the curl of E is equal to 0. That is because E is equal to the gradient of some scalar function. And we know that the curl of a gradient is equal to 0. So nana siya sa atong previous discussions, no? All right, so it is often easier to analyze a physical situation in terms of potential, which is a scalar, rather than the electric field strength, which is a vector. Okay, so let's end our discussion here sa class. And then hopefully by Tuesday, tomorrow we will have our exam, no? So by Tuesday, I will be able to go to the office of the record lang ni sa class.